Okay, so hey, I'm Miriam, and this talk is going to be about mini-maps. So, the question is motivating, what is a mind? And a mind is a mini-map of the world. What are the dimensions of the mini-map? Well, the first two dimensions are good and bad. That's the first dimension, is that continuum. And then you have three spatial, and you have the one temporal. And, well, that's as far as I got. Movement through space. Movement through configuration space. Space-time and configuration space-time. So, for example, the center of mass, I have one center of mass which moves translations in three-dimensional space. Then each of my joints is also a symmetry group of circles. So the full configuration space of, like, I'm moving through space, but I'm moving differently. Like, it's the same spatial movement, but the path through configuration space, which is the different positions my body can take. Well, and then we have good movements and bad movements, don't we? Movements that feel good and movements that... I don't think I'll be doing that one again. Classics. What are the classic movements? This is a good one. Hug. Hug movement. What's the meridian for that one? It's the one that goes along your middle finger. Hug. Is it pericardium? Hug meridian. Any of these pure movements that are based on the meridians. What are the meridians, I hear you ask? Well, let's see how many of them I can remember. Because, well, the way that I'm trying to remember them is by the finger and the finger and toe that it comes out of, but also the movement, because the movement activates the line and you can actually feel it going through to your finger, which is really cool. So, for example, stomach. We can start with stomach meridian. That's just forward bending, just letting everything bend forward. Bending my knees, I'm just going into the full Jefferson curl, curling up into a fetal position, I suppose you could say. It's the index finger, stomach, draw the hand, that one, and the posture is the curling all the way over. That's rude. I'm sorry, I shouldn't have done that. It's okay to do this one though. That's what horses do all the time. Just to say, it's okay, mate. Don't worry about it. You're doing great. Okay, maybe I'm gifting you a little sprinkle of water. I'll stop doing it. It's a library, or it's a shared space. So I'm sorry. I really am. Just doing a bit more stomach meridian right now. The thumb, that's lung. And the action of that one is stop. MF. I said stop. Punch. And I can feel it spiraling through my toe as well. So it goes through, it's a spiraling motion in my leg and a straight motion in my hand. So the one that in the leg that it's linking to, well, maybe it's liver. I don't know. That's your everyone's homework is to work those out, because I have ADHD and I'm trying to get a diagnosis so I can get some Adderall, but in the meantime, it's very hard for me to finish long projects like this. So I would love anyone's help with that. And I'm trying to think, what else did I want to say about minimaps? When I was a kid and I used to play on the computer games, and you'd have the little mini-map in the corner. So a tiny little low resolution. It was low spatial resolution. It's just a finite amount of pixels of space. Grid system. Just watching a little coloured pixel move around a grid system. And I'd be playing the game and I'd be watching the little pixel instead of actually watching the whole big scene. Because I guess my brain was so overstimulated that I didn't have the steam to process anything more than that. So the mini-map was my reality, which probably was about the same reality as maybe a small single-celled organism. Well, no, because I was trying to think of how a nervous system's built up from single cell organisms. Like E. coli's nervous system has, I think it can tell if there's like acid, and if there's acid, then it freaks out all its flagellas and spazzes around. So that's his simplistic view of the world. A pH scale and a cutoff. So that's his one dimension of reality. And his judgment of good and evil. And then I was just trying to think, building up to, like, we know ants learn to navigate by landmarks, for example. So they have this mini-map and they can teach each other take each other on walks to learn different paths through the terrain. So I'm sure ants have, like, actually literally a low pixel mini-map in their head of the space around them. So that's the point of a nervous system, of a brain, is to model the world as best as you can. And so the first thing is mapping it in terms of these are the places that feel good and bad, and then those judgments and discernments can get more and more finer as the brains get bigger and bigger. And I think there's some sort of a recursive complexity that we call sentience or whatever, which once you get to that stage, you sort of reach universal consciousness in a sense. Everything else will just be loops and variations of the same up to that. So. And I have this probably overly simplistic idea of this tower, which goes, how can I get it out? Well, for example, okay, so you have a one-dimensional movement. So one-dimensional loop. And it can be in multiple dimensions. So there's a synchronized hand and back motion here, which I could be using to swing a pickaxe or row a boat or whatever. Work. So that's the basic unit of work. Dare we say quanta? Why not? When you have two independent cycles, you can get a syncopated polyrhythm. So what does syncopation give you? You have two different ba 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 ba. I can feel there's two cycles. One goes that's in my back, I guess. And then the and that's like a closed path of two loops of energy. How can I draw that? It's an elliptic curve, or a torus for the topologists. And incidentally, to go from two dimensions to one dimension corresponds to pinching a point of the torus and erasing one of the dimensions. So say I'm doing this jiggly thing, and someone says stop dicking around with your hands. Uh-oh, you controlled me. Now I'm only one dimension. Uh-oh. That's scary. That's scary. That's when the robot can very easily model you. Once you get up to elliptic curve level, you just need to have those 2 cycles vibing around. You don't need genuine creativity, but you do need to be able to keep your own little boundary of space going and not be influenced too much to break down your little cycles. So 3 dimensions. That's I want to write it as the ohm symbol. How does that one go? Is it something like that? I'm thinking about how it's got 3 cycles. So that's, if you have the 3 cycles, you can kind of get arbitrarily non-repeating structures. What do we call it? Aperiodic crystals? I'm just going to write aperiodic crystals. Okay, and then we're just going to rub out what's above here right now, and we can go over it. So after 3 dimensions, this is where it gets hazy, but this is just my conjecture, is that I don't know why I feel embarrassed saying this, but I think that the configuration space of a 3-dimensional energy locus, is that the word? Traveling through configuration space-time is the exceptional Lie group E8. And then somehow this gives us an inclusion into the Conway group, which has a construction as a quotient of E8 3 times. And then somehow we're going to get into the monster group. So that's right. I think the reason why I think that this is the one for the people is because basically if we model the body so there's like 3 different axes. So we have these different each circle here is a ball joint, right? Which gives you, I'm just going to say SO3 worth of motions. It's the space of all circles. It's like, how many different ways are there to go around the world? You can go around the middle and around the top in all the different ways. I think another way we can talk about that is real projective to space. And, well, there's 3 different ways that we can pair them. So I'm going to colour them in, let's say, red is shoulders, and then blue is hips, and then black is neck and, I don't know, it's like the top and the bottom of your back. So there's like 3 different pairings of it's SO3, and then plus we also have the knees and the elbows. And the back has a bottom curve and a top curve. So the dash like that, that's a hinge joint, is that what we call it? And U1 is the group. It's just an angle. An angle between 0 and, what do you call it? 2 pi. Just an angle. My elbow can't go the whole way, obviously, but it's lives inside that space. It's a compact. Is it compact or is it? It's compact. It's a compact subset of U1. I don't know, I guess. And right, so with each of these pairings we get like, what do you call it? You get so SO3 times U1, and then we get the same for the other colours. And then for the black. So that's like a 24-dimensional configuration space. And there's actually lots of different relations. So like the different joints are connected by fascia along the meridians, basically. So the 12 meridians is going to help us cut out the algebraic variety, which is actually the locus of the configuration space that's possible. So the different restrictions, whether it's the hard and the soft limits, and then whether it's the connections along the manifold. Anyway, just to finish this thought, This is very sketchy, obviously. So if we have a person and another person and they're dancing, and I'm thinking maybe you get Conway group worth of configuration space, and then maybe when you put a third, we know that 3 is the magic number. And then maybe after that, everything just repeats. I don't know. I'm embarrassed to put this out here, but here I am. So thanks for watching, I guess.